Hi, so this is just a review of how the Triboelectric Series works. And when we're talking about the Triboelectric Series, this is pretty much the one classic question that we have with static electricity. And one thing that we have to realize with static electricity is that when we're dealing with static electricity, we're talking about electrons at rest. And that differs greatly from dynamic electricity, because in dynamic electricity, my electrons are traveling in a circuit. So what happens in static electricity is that I have a buildup of electric charges. One thing that we need to remember is that electrons have a negative charge. That's why the electron is E minus, and protons have a positive charge. And we also have to realize that electrons, they're the particles that are mobile. So when an item becomes negatively charged, it gains electrons. When an item becomes positively charged, it loses electrons. Now, with the Triboelectric series, it primarily is used when I am charging by friction. And when I'm charging by friction, I'm literally rubbing two items together. So let's do a little recap of what charging by friction means. And I'm using my trusty Shaun the Sheep to help me here. So what I have right here is I have a piece of wool and I have a piece of glass. And when I'm charging by friction, I am, first of all, electrically neutral. So I see that I have the same number of electrons and protons in the wool, same number of electrons and protons in the glass rod. And what happens is I rub the two together. And during this process where the two materials are rubbed, I have the movement of electrons from one material to the other. So if we're looking at this right here, I see that the wool takes on the electrons from the glass, so it becomes negatively charged. And the electrons leave the glass and go into the wool becomes positively charged. And how we can predict what items are becoming positively and negatively charged is our Triboelectric series. So whenever you have a question with the Triboelectric series, you have to be given the chart, right? You're not expected to memorize it. You're going to be given the chart. And what you have to do is you have to be able to read the chart. Now in our Triboelectric series, we'll see that we have one end of the chart where we have our items are gaining electrons. So that means that they're going to end up with a negative charge. And we have one part of the chart where our items are losing electrons. So they're going to have a positive charge. And what we actually have to do here is you're looking at the relationship between two materials. So if we were looking at wool and glass, we see that they are down here. And it's always a position-based chart. We can see that glass is closer to the positive end than wool. So that means wool is going to have a negative charge and glass is going to have a positive charge. And one thing that's really important about the Triboelectric series, and you need to remember, is that one will be negative and the other will be positive. And it really depends on what material is rubbed with what material. So we're going to do a couple of examples here to look at that. So our first example is that we rub gold with cotton. So what we need to do is we need to find gold on our Triboelectric chart. So gold is right here. And we need to find cotton, and cotton is right here. Now, if we notice from our chart, we see that gold is closer to the negative end. So gold is going to have a negative charge. Cotton is closer to the positive end. Cotton is going to have a positive charge. And it really is as simple as that. So we have another example, ebonite and vinyl. So we're going to look at our chart. We see that ebonite is right here. Vinyl is right here. So in this situation, vinyl is going to obtain the negative charge and ebonite is going to obtain the positive charge. And what's really important is always situation specific. So what happens in one situation might not happen in a different situation, and you really need to look at what's happening in the two materials that you're rubbing with each other. So we're going to look at one more example. In our last example, we see plastic rubbed with cotton. So we have plastic here, we have cotton here. So when I'm rubbing plastic with cotton, plastic, because it's closer to the negative end, is going to take a negative charge. Cotton is going to take a positive charge. In our second scenario, we are rubbing silk with glass. So silk is here, glass is here. Glass is going to take on a positive charge, and silk is going to take on a negative charge. And whenever you have something like this, then they'll tend to ask really common questions like, what happens when you bring charged silk close to charged cotton? So once you've actually determined the charges, you look at your chart, you see that cotton had a positive charge, you see that silk had a negative charge. So when I bring the two together, well, the result is that they are going to attract, because remember, opposite charges attract. So let's say I had a question where you bring charged silk close to charged glass. Well, again, we look at our chart. We saw that silk had a negative charge. We saw that glass had a positive charge. And oh, look, they're both going to attract. So when we're looking at the triboelectric series, we need to remember that it is always situation specific. I have to look at the two materials that are being rubbed, and I need to look at where these materials are in relationship to the gaining electrons part of the series and losing electrons part of the series. And whatever is close to that is the charge it's going to take. And then from that, we could actually have questions of what happens when I bring the two objects together, whether they attract or repel.